Hi folks, welcome to the second video in the Euler's method notes. And so in this video, we're going to take a look at a second example where we use Euler's method to approximate a solution, okay? So keep in mind what we're doing here is we're trying to use the idea of straight lines, tangent lines, to get really close to a solution that we're interested in, okay? Because maybe that solution is more complicated than we want it to be, but maybe we all also just want to be able to get close enough to an answer. Okay, so we're going to take a look at example 2. We're going to follow the same steps as we did in example 1. So hopefully you've gotten a head start on this and you feel pretty good about just checking your work here. Okay, all right, so consider this differential equation y prime equals 3x minus y, and the initial condition y of 0 equals 4. It says use Euler's method with a step size of 0.5 to find the approximate value of the solution at x equals 1.5. And so just like last time, let's start with a quick graph so that we can kind of keep track of what it is that we're finding, okay? So I know that y of 0 equals 4 means that like I'm starting at this point 0 comma 4. And I'm using a step size of 0.5. And so like I have 0, I have 0.5. How many times do I need to jump by 0.5 to get all the way to 1.5? Well, I need to go once I get to 0.5. I go a second time, I get to 1, and a third time, and I get to 1.5. Okay, now the step size won't always be 0.5, but I thought for the examples that we're doing by hand, like I don't want us to do too many different calculations here, okay? So in this case, we're going to set everything up with our information, and then we're going to repeat that process that we did in the previous video 1, 2, 3 times, okay? The first time will get us to this x1. The second time will get us to x2, and the third time will get us to x3. Okay, so I'm actually going to notate that right now. This is our x1, this is our x2, and this is our x3. Okay, and this 0, this is our x0. So I've started at the x0. I'm going to take one step to get to x1, a second step to get to x2, and a third step to get to x3. Okay. All right. So let's think about all of our information so that we can have it handy. All right. So our y prime is 3x minus y. All right, so this time I don't have to move anything away from the y prime. It's already by itself. All right, now I know my step size is 0.5. That's how I got my diagram. And I also know that my x0, y0 is 0 comma 4. Okay? All right, so let's start by figuring out how to go from x0, y0 to x1, y1. Okay, and maybe that's a better way to sort of write that first to describe the step. So go from x0, y0 to x1, y1. Okay, all right, so let's write down our equation for that slope. So we've got y1 equals y prime of x0, y0 times x1 minus x0 plus y0. Okay, so this is probably the smoothest form of the equation. You can start back where we did in the last video, but that's more just to show where it comes from. This is probably a good place to start. Okay, so what do we've got? We got to find our y prime at the point that we're starting at. We're going to plug in our x0, we're going to plug in our y0, and then I ran out of highlighter colors, but we're also going to be plugging in our x1. Okay, so everything on that right-hand side should just be a number. Okay, so we've got y1 equals. Okay, now my y prime, if I look back, is 3x minus y. That's 3 times 0 minus y, which is 4. So I'm just plugging in my x0, y0 into my y prime. All right, my x1 is going to be 0.5 because I'm stepping 0.5. Minus 0 is where I started, plus y0, which is 4. Okay, so let me just make this a little bit smaller, but I'm just using my x0, y0 and plugging those into my y prime to get this green part. And then my x0 and y0 also go here, but my x1, we already said, was 0.5. That's where this 0.5 comes from. Okay? So we work this out, we get y prime, sorry, y1 equals negative 4 times 0.5 plus 4, and that gives us negative 2 plus 4, or 2. And what this means is our new point, okay, is x1, y1 is going to be 0.5, comma 2. And if we think about that on the graph, what that means is that at 0.5, it has a y value of 2. Okay, the solution has a value of 2 as an approximation. Okay, so we went through this process one time. We got from x0 to y0. Now we have to do it again to get from x1 to x2. And then we have to do it a third time to get from x2 to x3, and then we'll be done. Okay? So let's start with the next process. This time we're going to go from x1, y1 to x2, y2. Okay? And all that's going to mean is that I'm shifting the numbers that I'm using here. I'm not starting with x0, y0 anymore. Now I'm starting with x1, y1, and I'm going to x2, y2. So that is going to look like y2 equals y prime of x1, y1 times x2 minus x1 plus y1. All right, so I've kind of left this one up here on purpose so we can kind of see them side by side, right? Where we've changed the numbers. Everywhere there was 0, 0, now we're changing those to 1, 1. Everywhere there was a 2, or everywhere there was a 1, now we're changing that to a 2 because we're just moving 1 over. Okay? All right, so y2 equals 3 times our x1, which is 0.5, minus y1, which is 2. Our x2 is 1, minus the x1 is 0.5, plus my y1, which is 2. I think part of the hardest bit here is just figuring out, making sure you're plugging numbers into the right place, okay? Beyond that, it's just a lot of calculations. So we've got y2 equals, let's see, 1.5 minus 2 times 0.5 plus 2, and that gives us 1.75. And what this means is that x2, y2 is 1, comma 1.75. All right, so let's throw that back on our graph. 1 and then 1.75. So 1 comma 1.75. That's our new approximate. Okay. Now we got to go one more time to get to our x3 value, and then we'll get our y3 value, which is our approximate solution. All right. So step 4. Now we're going to go from x2, y2 to x3, y3. Okay. All right. So now everywhere there's a 1, I'm going to make that into a 2. And everywhere there's a 2, I'm going to make that into a 3. So we're just shifting everything up by 1. y3 equals y prime of x2, y2 times x3 minus x2 plus y2. Now again, I think the hardest part is just plug in our value, so let's do this really carefully. y3 equals 3 times x2, which is 1, minus y2, which is 1.75. My x3 is 1.5, minus my x2 is 1, plus 1.75. Okay? Now you're probably going to start to get more decimals as you go. It's not a bad thing. It doesn't mean that you're doing anything wrong, but as we get closer and closer to that approximation, we're going to get more decimals, and that's actually okay. All right, so y3 equals 3 minus 1.75 times 0.5 plus 1.75. And when we work this all out on the calculator, we get 2.375. And what that means is that my x3, y3 is 1.5, comma 2.375. Okay, so let's throw that back on our diagram. Let's see, we've got 1.5 and then this one, so this is 1.5, 2.375. That means that our approximate solution is 2.375. Okay? So if I get this all on one page here, right, let's kind of think about what we're doing. So we're breaking it down step by step, and we're only using the idea of derivatives and slopes and lines to get us close to an actual solution. Okay? So I do recommend starting with your diagram just so you can kind of see like how it is that you're breaking things down and like how many times you have to repeat the process. Okay. All right. Well, that's it for this video. Let me know if you have any questions.